Hey everyone. Today I'm going to go through a handful of slides from our LT10 notes. The slides I'm going to go through are 10 through 14 and then 19. The ones that we skip we're going to be doing tomorrow or Friday, depending on which day you have class with me. But I want you to watch these. I want you to fill them out yourself, and then I'll talk about your homework before we leave. So I'm on slide 10. We have to remember that the independent variable represents the input, and the dependent variable, which you can't see on my screen, but you will see on yours, the dependent variable represents the output. And we briefly mentioned yesterday or Monday, depending on when you had class, how these two things relate. And we had our dependency statement of output depends on input. So we're going to go through a couple examples of picking what depends on what. So example number 1, number of apples picked versus number of pies that you can be made. Looking at these two, you think, does it matter? Does the number of pies that we made tell us how many apples we picked, or does the number of apples picked tell us how many pies we can make? And I'm hoping you see that the number of apples is the thing that you control. You go to the orchard, you pick as many as you want. Not realistically, but you get the idea. And then depending on how many apples you pick, that is going to determine how many pies we can be making. If you don't have enough apples, you can't have the pies in the first place. You can't have the pies without the apples. So our dependency statement is dependent depends on independent. Number of pies depends on number of apples picked. Looking at this second example, grade earned on a test versus hours spent studying. I want you to think about this even better if you pause for a moment. You know what? I might do that myself. I'm going to pause. I'm going to come back and the answer is going to be here. You should pause and take a guess at what it should be. Okay, we're back. So looking through these two, it would make sense to say that you can choose how many hours you study. You can't choose that grade on your test. That grade on your test depends on how prepared you are for it. And generally, studying helps prepare you for tests. So the hours spent studying is your independent variable. Your dependent variable is the grade on the test. And our statement would be the grade you got on your test, the grade you earned on your test, depends on how much time you prepared, how much time you studied. Oops, sorry about that. So the next thing we're moving into is writing function rules. So we're going to read through a problem, and then we're going to start by coming up with a way to calculate the costs, and then we're going to come up with a generic way to do that. So roses are red sells each rose for 75 cents, plus there's a one-time fee of $20 to set up your account. Complete the table to identify a function rule to represent the situation. I'm going to do a couple and then ask you to fill out the rest of this table here. So if we read through that statement again, they sell each rose for 75 cents each, plus there's a one-time fee of $20. So to set up the account, you need to spend $20. Then if you're ordering 12 roses, each rose costs 75 cents, and we'd multiply those together. Now, if you got a calculator, this might be a little bit easier. If you don't have a calculator, feel free to grab one or just, I guess, wait for me to write down the numbers. But that is 9 plus 20. Overall, your cost would be $29. I'm going to do one more and then ask you to fill out the other two. So if you ordered 24 roses, you'd still pay that one-time fee of $20, but then you would pay 75 cents for all 24 roses each. And then 75 cents times 24 roses is $18, so our total cost would be $38. Try to fill in the processing cost for the next two, and then we'll talk about that last line X. Hello. So each of our next two rows, same process. It's $20 fee to get started, create your account, and then it's 75 cents per rose. So we do 20 plus 75 cents times number of roses, which will give us our costs. Now, this last line has X, and I want you to see what we did. 12 and 12, 24 and 24, 36 and 36, 50 and 50. So what are we asking for X? We're not asking you to do anything different. We're asking you to follow the rule and write it with X. So our rule that's going to help us calculate our roses are red cost is 20 plus 0.75, X. So we're going to name our function R. We can name it whatever we want. We'll name it R for roses are red. And our function rule is 20 plus 0.75x. Now we're going to keep that for later. We're going to come back to that. On the second page, on the next slide, we have a different flower company, Flower Power. How are they different? They sell roses for 50 cents each, but they have the one-time fee, which is $60. So I'm going to do one, and then I'm going to ask you to fill out the rest of this table before you come back and check out the answers. So for Flower Power, we have the $60 one-time fee that we're adding to 50 cents for every rose. So 50 cents times our 12 roses. In total, that cost is going to be $66. I want you to use this in the idea from the last table. I want you to see if you can fill in everything. When you come back, I'll have the answers for you. So what'd you get? Hopefully every column, or excuse me, in every row you have a 60 plus 0.5 times number of roses. So for our Flower Power, let's call it f of x. What is our rule? Our rule is that one with the x. It's our $60 one-time fee plus 50 cents times every rose. And when we don't know how many roses we're buying, we write it with X. So these tables are going to help us start developing our way to write functions. So for both roses are red and Flower Power, which variable represents the independent variable? So what is the independent variable for both of these? What's the thing that we determine? When you go into the store, you're choosing how many roses to buy. So your independent variable is number of roses. While your dependent variable, what depends on the number of roses that you buy? That's going to be our total cost. The thing that we're calculating with our function. So I keep sliding back and forth here. But the number of roses that we order tells us how much it's going to cost us. So writing our dependency statement, dependent depends on independent. Let's write that our total cost depends on number of roses ordered. All right, our rules from the previous page. Let me see if I remember these without having to look them up. Remember the last one was 60 plus 0.5x, so that was Flower Power, and our first one was $20 fee plus 75 cents per rose, so 20 plus 0.75x. Which store would be better if you were planning on buying 75 roses? Roses, if you can recall from above, is our independent variable. And do we remember what our independent variable relates to? That's our input. So which store would be better? Better in this case, I hope you think, means cheaper. I'd rather shop at the cheaper store, assuming that they have a similar product. So what we're going to do is we're going to take our functions R and F, and we're going to input 75 to see which one is better for us. So what is R of 75 and what is F of 75? Now you've practiced this a little bit, so it's in your best interest to pause now, see if you can come up with each of these costs and see which one is better. When you unpause in a moment, you're going to see the answers from me. Welcome back. So when we input 75 into R, into the function r for roses are red, we do 20 plus 0.75 times 75. I used my calculator and got $76.25. For flower power, we're still going to put in 75. So we replace x with 75, and we get 60 plus 0.5 times 75. When I plug that into my calculator, I got 97.50. So I'm hoping from this, you would say which one is better. I'm hoping you would say that roses are red because it's cheaper. By how much? I'm going to jump over to my calculator and do $97.50 minus $76.25, and it's by an amount of $21.25. That's like a couple lunches right there. So roses are red would be the better store if you were buying 75 roses. Which store would be better now for number 2 if you were buying 250? So I'm going to run through this one with you right now. 250 roses is our input, so we're going to input that into our functions. So we get 20 plus 0.75 times 250, and then for f, it's 60 plus 0.5 times 250. Now I'm going to jump over to my calculator again, and I'm going to calculate. Over here for roses are red, it looks like it's going to cost us $207.50. For flower power, looks like it is going to cost us $185. So now when you're buying more roses, 250 to be precise, which store is better? I'm hoping you're telling yourself flower power would be the better store, as we are a bunch cheaper. We're now more than $20 cheaper on that way. So these problems are asking you to use your function rules and plug in things to solve for costs. Okay, we got a couple more questions based upon these. So I'm going to rewrite our function rules from above, carrying them along. So our roses are red function was 20 plus 0.75x. And our flower power function was 60 plus 0.5x, or 0.50. You could write 0.50 if you'd like. How many roses could you buy at flower power if you had $200? Now, this is a little bit different here. What's different about this question is it's not asking you about roses. It's telling you you have $200. You have the dependent variable right there. So what we want is when is our output $200? That is what this question is asking. So we don't plug in 200. We're thinking our output is 200. We're not going to put 200 in the input. 200 is not the input. So what do? We take our function and we want to know when it outputs 200. We set it equal to 200, and now we solve. So at this point, I'm hoping that solving is feeling straightforward to you. If not, always come talk to me. I'm happy to help. Since we're working with decimals, I'll allow you to divide by 0.5. And if you use a calculator, you will see that for $200, we can get 280 roses if we were to use flower power. So this one was a little bit different. This one, it gave us an output number. So we had to set our function rule equal to that number. We didn't plug in 200. 200 is not the input. It's not the number of roses. Same problem for roses are red. $200. If you were to do R of 200, that is going to be incorrect because this is our output. And when we want to calculate something for the output, we take our rule, 20 plus 0.75x, that's for roses are red, and we want to know when it's equal to the output. Same problem with the other function. So we're going to subtract 20 to cancel the 20s. We get 0.75x equals 180. And again, since we're using decimals, I'll allow you to divide by 0.75. 180 divided by 0.75, we get 240. And what are we solving for? How many roses? So roses are red, we can only buy 240 roses. So that's a little bit different there. For the slide before, we were calculating what our cost would be depending on how many roses we bought. Whereas in this slide, we were saying we only have this much money, we only have this much output. How much input could we have? And we calculated it that way. So now what I want you to do is jump all the way over to slide 19. We're going to do a problem together, and then I'll talk about your homework. Looks like can't see everything, so make sure to be looking on Class Kick when doing this. Have them side by side. Cougar Fitness has 2 payment plans. You can become a member by paying $200 entrance fee, then $3 per time. Looks like mine cut off. I gotta bring up my other screen here. Give me one moment. Sorry about that. So I'm going to read the problem again. Cougar Fitness has 2 payment plans. You become a member by paying $200 entrance fee and then 3 times every time you visit, or you remain a non-member and pay $13 every time you visit. So we're going to do this problem without that table and see if we can come up with our function rule without having to write all those steps. So let's think about what's going on here. We have 2 payment plans. So something we're doing depends on is cost. And then what other thing is happening here? It says per times you visit. So we have 2 variables going on. It's visits and it's cost. Do you know which one depends on which? The cost depends on the number of visits. Now part B says write 2 function rules to represent the different situations. Make sure to define your variables. So our inputs, we're going to call those x. X is our independent variable. X is going to be our number of visits. Ooh, I spelled that wrong. Now let's talk about our 2 different things we're calculating. One's going to be members. So let's call one of our rules m of x for members. And then I guess our other plan would be n of x for non-member cost. So let's think about our m of x. Reading the problem, you become a member by paying $200 fee and then $3 every time you visit. So we have a one-time fee of $200 plus 3 times every time we visit, and we're calling our visit x. So there's our m rule. How about our n rule? You remain a non-member and pay $13 every time you visit. So for n, there isn't an initial fee. There isn't just a fee that you pay. It's just $13 every time you visit. So there are our 2 rules. And then wrapping up with our last 2 parts here, how much will it cost for 15 visits? So that is our input. Remember, x is our number of visits. So we're going to do m of 15 and n of 15. What is m of 15? We replace x with 15. That is 200 plus 3 times 15, which is 200 plus 45. It's $245. For non-members, we replace x with 15, so that's 13 times 15. And I don't know this off the top of my head. I'm going to go to my calculator. And it looks like $195. So if you were only going to go to Cougar Fitness 15 times, it looks like being a non-member is the way to go. It's cheaper by $50. And then our final, how many visits will it take for the 2 plans to cost the same amount? This was a question on the test a handful of weeks ago that a lot of people had trouble with. How many visits till they are the same? What do we want to be the same? We want the member cost to be the same as the non-member cost. We're going to take our two equations, our two function rules, and set them equal to each other. 200 plus 3x, when is that equal to 13x? And while this isn't a simple equation to do, it's not too bad if we subtracted 3x from both sides. To cancel the 3x's on the left, we get 200 equals 10x. We divide by 10 to cancel that 10, and we get our answer of 20. Now, how do we write this using some labels? What is x? 20 visits, and they cost the same. So if you're going to go 20 times, it doesn't matter which one you choose. It'll only matter if you go less or more than 20. Okay. That is all I'm doing with you today. Thank you for the 21 minutes. Your homework is spelled out on Google Classroom. It is slides 3 and 4 in the homework on ClassKick that you started 1 and 2, pages 1 and 2 on. So if you have questions, let me know. We can talk through email. You can join me for some office hours stuff. Yeah. Have a great day, and I'll see you tomorrow or Friday.